Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting topic in 8051 microcontroller. We're going to see the interrupt operation of 8051, right? In this video we're going to see what is interrupt, how the interrupt is generated in 8051, right? What are the different types of interrupts that the microcontroller can handle, right? So before starting this video, I'll just tell you what is interrupt. Any operation, it can be a controller or any processor, right? So any particular operation which halts the CPU process, that is called as interrupt, right? So if for example, the microcontroller is executing any particular program, right? And you know that every program, that is whenever you give any instructions, right? Even in your lab you'll give instructions to with memory locations like 4100, 4102, like this. You'll give instructions, correct? So the microcontroller will start executing the instruction one by one, right? So this is the main instruction. So say for example, if there is an interrupt, right, what will happen is it will stop the execution of this main program. And what this interrupt will do is it will stop the execution of this main program, and then it will branch the microcontroller to another location, right? It will make the microcontroller to go to a different location and execute some other instructions there, right? You know that the branching instructions we use, call instruction, jump instructions, right? So it will go to a different location and it will execute another set of instruction, right, which is the interrupt instruction, we can call it as, or maybe a very urgent instruction that has to be executed now, right? And after executing this interrupt instruction, you will have RET, that is return instruction, which will make the microcontroller to go back to this same location. Clear? Right, this is the normal operation that microcontroller will do whenever there is an interrupt, right? So it will stop the main execution, it will go to a different location to execute a different set of instruction, and it will come back, right? And in this video we will see how this process is taking place, right? So first, before seeing all those things, an interrupt is an external or internal event that happens inside the microcontroller, right? And the main advantage of interrupt is it can able to serve several devices, right? So we know that we have an external oscillator, timers, all those things in microcontroller, right? So it can able to serve all those devices uh, because of this interrupt, right? So this can be generated in two different ways, right? One is whenever there is a need, whenever there is a need of an interrupt, right? Say for example, if a device need a service of microcontroller, what it will do is it will intimate. Normally, what it will do is it will intimate the need of the service to the microcontroller by generating the interrupt, right? In previous video we have already seen about TF flag, right? What is TF flag? Whenever the TF flag is enabled, the timer interrupt is generated, right? So like that, whenever there is a need for a device, right, to serve by the microcontroller, what it will do is it will create the interrupt, right? And as soon as the interrupt is created, the microcontroller will serve that particular interrupt, right? As I said, it will go to a different location and it will execute all those instructions, right, and come back to the main program, correct? Right. So now this location, right, where it goes, that is called as ISR, which is nothing but interrupt service routine, right? So this is one way of handling the interrupt. The device will generate the interrupt and the microcontroller will go to that location and it will generate, right? Or else there is another method which is called as polling method. So what is polling method? The polling method, in polling method, what it will do is that the microcontroller will poll each and every devices. For example, it will go to the timer and it will watch the timer, right, until the timer interrupt is generated. It will wait, right, and once it is generated, it will serve that interrupt and then go back to the next device, right? This is called polling method, right? You can see here the microcontroller continuously monitors the status of any given device, and when the condition is met, it performs the service, and then it moves to the next device, right? And obviously the interrupt is help to serve a more number of devices, but in polling method it is not very efficient, that because it has to continuously monitor a timer, right? And until it generates interrupt, right, it will wait, and once it generates interrupt, it will serve that interrupt and it will go to the next device, right? And because of that, more time is getting wasted. For example, if you see this particular condition, we are very familiar about this particular instruction, jump if not bid, right? That is, if TF flag, right? I've already explained this particular instruction many times in previous videos. Please go through it, right? So this particular instruction, what it will do is it will wait until TF flag becomes 1, right? Until if it becomes 1, it will be looping into the same loop address target, right? So until it becomes 1, it will be looping in the same location. That is, microcontroller will be waiting in the same location, right? And once it reaches to 1, it will go to the next instruction. So because of that, the time it's getting wasted. It is very inefficient. The polling method is inefficient, right? And as I said, the device, each and every device can get the attention by generating the interrupt. And I already explained about the priority of interrupts, right? You have 0 priority, 1 priority, what are the different interrupts and what is those priorities, right? But those priorities is not applicable in polling method, right? And also the microcontroller has one particular advantage, that whether it can decide whether I'm going to serve this particular interrupt now or not, right? That is, it can able to ignore the mask, right? That is, a microcontroller can also ignore a device requesting a service, right? But that is not possible in polling method, right? And you know that when it will ignore, say for example, we have timer 0 and timer 1, right? Timer 0 and timer 1. If it is serving the timer 1 interrupt, and if a low priority interrupt comes, then what will happen is it will ignore that interrupt. Only after completing this one, it will go to the next one. Correct? I have already spoke about priority of interrupts while explaining the architecture, right? So that is not possible in polling method as well, right? Now, as I said, for executing the interrupt, that is, it will stop the main execution, it will go back to the another location which is called as interrupt service routine, and then from there it will go to the main program, right? Now we will see what is the technical aspect which is happening here. How is that the microcontroller goes to a different location, right? How is that it comes back to the main program, right? So that is what we're going to see, how the interrupt is served by the microcontroller. Okay, so whatever interrupt which we have, we want to understand that when whatever interrupt is generated, each and every interrupt will have its own memory location. I will show the memory location in the next video, but as of now, you understand that for every subroutine you will have a memory location like 0001, 000BH, something like that, right? So now whenever the interrupt is generated, then what will happen is the microcontroller will understand that I have to go to this memory location, right? So this particular memory location, which has this interrupt service routine address, that is called as interrupt vector table, right? And each and every interrupt will have its own memory location, and it will be saved in the interrupt vector table. All right. Now, as I said, whenever it is executing the main program and an interrupt is generated, it will go to the subroutine. It will execute that instruction and come back to the next instruction. Come back to the main program, right? How is the microcontroller stops the main program, go to the different location, come back to the same location and execute the same instruction from where it left, right? Technically, how this is happening? We know that there is something called program counter. What is program counter? Program counter is the one which holds the information of the next instruction that is getting executed, right? And you know what is IR? Instruction register is something which holds instruction, which holds information about the current instruction that is getting executed, right? Now, whenever the interrupt is generated, right, we know that the microcontroller will do a step-by-step execution process, right? Say for example, if 402 and this is 403, whenever if an interrupt is generated at 402, now what happens whenever an interrupt is generated, it has to go to a different location, it executes some program and then come back to the main program, and then it has to execute from 403, not from 402, right? Just for an example, I'm giving this address location. So how it exactly does that, right? That is, whenever there is an interrupt, what will happen is the first thing the microcontroller will do is it will complete this execution, right? And it will stop the main program. And now what it will do is it will copy the next instruction address. This is the address of the next instruction, right? And it will use push operation. You know what is push and what is pop, right? Push and pop is used to increase the stack and decrease the stack. That is, whenever you need to increase the stack value, that is to load some information in the stack pointer, we use push operation. And whenever we need to remove an instruction from the stack pointer, we will use pop operation, right? And you know what is stack, where we temporarily load the information, right? So as soon as the interrupt is generated, right, what microcontroller will do, it will push this up, this address, push post 03 to the program counter, right? So now the program counter, it will be saved to the stack pointers, right? Now what it will do, it will copy this 403 and using this push operation, it will save to stack pointer, right? And what it will do is it will stack pointer, and then what it will do, it will go to the subroutine, and then it will serve that particular subroutine. And in subroutine, you will have an instruction which is called as RET, return instruction, right? And as soon as it reaches that return instruction, what it will do is now it will once again go to the stack pointer, which is by using pop operation. Now it will move this 403 to program counter, right? And once this particular address reaches program counter, then that is the instruction which we are going to execute, right? So it will automatically go to the main program and it will start executing the main instruction, the next instruction. Clear? Just for an example, I'm using this 403, but this is how it will work, right? Whenever there is an interrupt, it will push the next address to the stack pointer, and while returning, it will pop that address from the stack pointer, right? So whatever I said, that is what given here, right? And you can see here, it uses the stack pointer, right? It will move that particular next address to the stack pointer, and then it will freezes that interrupt internally. And then what happens? It jumps to the memory location of the interrupt. It will serve that interrupt until it reaches this RET, right? It can be RET or RETI. If it is interrupt, then it will use RETI, which is return from interrupt. What that instruction will do is it will not only return to the main program, it will also reset the interrupt flag. Say for example, if TF flag is created the interrupt, while returning to the main program, this flag will be automatically reset to 0, right? And while resetting, what it will do is it will go to the it will pop the address, right? Pop that particular address to the program counter. Whatever I said, I have just written in points here, the same operation, right? So before serving the interrupt service routine, what it will do, it will push the address to the stack pointer, and while returning from the service routine to the main program, it will pop that address to the program counter so that it will continue the execution from where it left, right? This is how it will serve the subroutine, right? So today what we have seen is, we have seen what is interrupt, what is different ways of generating interrupt in 8051, how is that interrupt is executed in 8051, right? I believe this video will be very useful for you. Thank you, my dear students.
Thank you, students. Thank you for watching. கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும்னு நம்புகிறேன். Subscribe Passionate Professor and keep learning. Thank you very much.